Hello students, today we will study about the one of the word problem from the exercise 3.6 question number 2 sub question number 2. This is the topic of standard 10 chapter number 3 pair of linear equations in two variables. So this word problem is under the category of equations reducible to pair of linear equations in two variables. So the equations we formed from the given situations are not in the form of linear, right? So we will convert them it into the linear form and then find the solution. So what is the question? The question is, two women and five men came together, finish an embroidery work in 4 days, while three women and six men can finish it in 3 days. Find the time taken by one woman alone to finish the work and also that taken by one man alone. Right. So here the work of embroidery is given by together man and woman work. Right. So if they together can work finish in some days. But what will happen if only one man or one woman do that work? So how many days they taken? So let's suppose one man can finish the work in X days and one woman can finish the work in Y days, right? So if they can work, if they can finish the work in X and Y days respectively, what are their work of one day? So this is the given here. Work done by one man in 1 day is equals to 1 upon X and work done by one woman in 1 day is equals to 1 upon Y. You may have a question that why the 1 day work is 1 upon X and here 1 day work is 1 upon Y. So understand this situation. Let's suppose that one man can finish the work in 4 days, right? So as an average, he can finish 1 upon 4th part of the work in 1 day. Second day also he can finish 1 upon 4th part. Third day also 1 upon 4th part. And fourth day also 1 upon 4th part. So now if we add the total work of 4 day, we will get 4 as the LCM and in the numerator 1 plus 1 plus 1 is 4. That is equals to 1. 1 means the total work. This is the fraction of work. Whole work is 1. 1 day work is 1 upon 4. Right? So in the same way, if they can take total X days to finish the work, 1 day work we will get is 1 upon X. To understand this in another way, in percentage way, we can take 1 as a 100%. Let's suppose this is a total work and it is 100%. So 4 day work we can divide 100 into 4 equal parts if they can finish 25% of work in 1 day. So by doing that in 4 days they can finish the work 25% in 1 day, 25% second day, 25% third day and 25% fourth day. So total in 4 days he can or she can finish the work 100% work. So what is the fraction of 25 of 100? That is 1 upon 4 again. So 1 upon 4 is 25%. Again 1 upon 4 is 25%. 1 upon 4 25% and 1 upon 4 25%. So in this way you can also understand these things. So now this thing is clear in your mind that one man in 1 day can finish 1 upon X work and one woman in 1 day 1 upon Y work. So what is the two situations given in the question? First situation is two women and five men can together finish the work in 4 days. Now here we have the work of one man in 1 day and one woman in 1 day. So how many women are there? Two women in the given situation. So this is the one woman 1 day work. So two women can finish 2 into 1 upon Y work in 1 day. In the same way, 1 upon X is the work of one man for the 1 day. So 5 men can finish 5 into 1 upon x work in 1 day. And here right hand side, the total days are 4 days. So what the work done by altogether 2 women and 5 men for 1 day, that is also 1 upon 4. Right? Why 1 upon 4 we have taken here? You can understand from this now very well. Right? 1 day they can together finish the work 1 upon 4. On the second day together they can finish another 1 upon 4. Like this. Right? So that is why we have taken 1 upon 4 here. So what is this? This is the 2 women work for the 1 day. Plus this is the 5 men work for the 1 day. And this is altogether 2 women plus 5 women work for the 1 day. In this way we can form this equation. Right? So now we will take this 4 to the left hand side. We will get 8 upon y plus 4 5 is 20 upon x is equals to 1. This is the equation number 1. What is the second situation given in the question is 3 women and 6 men can finish the work in 3 days. So now we will take, we know that this is the 1 day work of 1 woman. So 3 women can finish 3 into 1 upon y work in 1 day. In the same way, this is the 1 upon x is the work of 1 man for the 1 day. Then 6 men can finish 6 into 1 upon x work in 1 day. How many days they are taking? 3 days. So what is the work done in 1 day is 1 upon 3. So this is the 3 women work for 1 day plus 6 men work of 1 day is equals to total is equals to 3 women plus 6 women for the 1 day. Right? So in this way we can get this second equation. Now take this 3 to the left hand side. We will get 9 upon y plus 6 3 is 18 upon x is equals to 1. Give it equation number 2. Right? So now let's see this slide next. So both the equations are written here. So 8 upon y plus 20 upon x is equals to 1. 9 upon y plus 18 upon x is equals to 1. We have formed these two equations, but they are not in the linear form. So to convert it or to reducible it to the linear form, now we will suppose that 1 upon y is equals to a and 1 upon x is equals to b. Okay? So these equations are reducible in the form of 8a plus 20b is equals to 1 and 9a plus 18b is equals to 1. Give it equation number 3 and 4. Now we can solve this pair of linear equations in any method. So we are taking the elimination method. To eliminate the variable a, we have to find out the LCM of 8 and 9, and that is 72. So we will, to set here 72, we will multiply equation number 3 with 9 and equation number 4 with 8 and subtract both the equation. Then what will happen? Here we will get 72a plus 180b is equals to 9. And multiplying equation number 1 with 4 with 8, here again we will get 72a plus 18 8s are 144b is equals to 8. As we are subtracting here, take minus sign. All three terms have changed their sign, right? So now this 72a plus and 72 minus will cancel out each other. 180b minus 144b, that is 36b, and 9 minus 8 is 1. So the value of b is equals to 1 upon 36. To get the value of variable a, now we put this value of b in equation number 4. So 9a as it is plus 18, in the place of b we can now put 1 upon 36 is equals to 1. We can cancel out here 18 2s are 36. What remain we have is 9a is equals to, right hand side there is 1, taking this 1 upon 2 to the right hand side, it will become minus. 1 minus 1 by 2 is 1 upon 2. So 9a is equals to 1 by 2. Again take this 9 to the right hand side, it will goes in the denominator. So a is equals to 1 upon 18. Now what is 1 upon y we have supposed is a. So 1 upon y is equals to a, and a is equals to now 1 upon 18. So 1 upon y is equals to 1 upon 18. So what the value we get here is y is equals to 18. Same way, what we have supposed 1 upon x? 1 upon x we have supposed is equals to b, and what the value of b is 1 upon 36. So 1 upon x is equals to 1 upon 36. Again we get the value of x is equals to 36. Now remember what we have supposed x and y. X we have supposed that one man work. If man alone do the total work, then he can finish the work is equals to x, and that is equals to 36 days. Same way, if one woman can do whole work alone, then she can finish the total work in y days, and that is equals to 18 days. Right? So one man can finish in 36 days and one man can finish in 18 days work. Right? So in this way we can solve this type of word problems. Right? Thank you.